Okay guys, today I'm going to do just a few examples of adding and subtracting signed decimals. Remember, addition is finding the sum and subtracting is finding the difference. Before I get to work on these, I'm just going to go down through here and put a parenthesis around the second one, because a lot of times in textbooks, if that second addend is negative, they'll put that set of parentheses around here. So I do want us to go back and remember that we're dealing with signed things, so we need to think about those integer rules. So I'm going to go ahead and I'm going to start with my t-chart here, and negative 5 3/10 goes on this negative side, and negative 64/100 also goes on this negative side. Now I'm going to try to go ahead, and I've lined up the decimals here because when we're adding and subtracting decimals, we need to make sure we line up the place values. Since both of these are on the negative side of my t-chart, I do just get to go ahead and add 0 plus 4. 3 plus 6 is 9. So I get 5 94/100. Remember, since they're both in the negative side, I add those like normal and keep the sign the same. So let's look at question B here. I think we can look at it and go ahead and see, but I have 5 3/10 on the negative side, 64/100 on the positive side. So that means since they're in opposite sides, I do not get to add those. I have to subtract. So I'm going to have 5.30, 5 30/100 minus 64/100. So I'm going to go ahead and again, I lined up those decimals. I'm going to borrow here, make that a what was that? That becomes a 2, this becomes a 10. So that's 6. I'm going to borrow again. That becomes 12 minus 6, which is 6. And then the 4, and I'm going to bring the decimal straight down. So I want to just go ahead and double check my work. I'm going to go ahead and double check that by adding 64/100 back here. So that's a 0. That's 12, 13. That's my 5. So it did take me to my original addend. So this is the answer that I got, 4 66/100. And since this guy, 5 3/10, is in the negative side, that means that sum is negative. Let's come up here again. Signs are in different spots. We could repeat the subtraction again, but it's going to end up being this same subtraction question. So we're going to still end up with a difference of 4 66/100. And since this is the bigger number, if we did do the t-chart, the 64/100 is in this column and the 5 3/10 is in this column. So the positive number is in the larger column. So here, I'm just going to actually go ahead and add like normal. And again, I'm not going to repeat the addition because I'm still going to get this 5 94/100. And in this case, since both of the addends are positive, we know that the sum just gets to stay positive. So I kind of did these 4 examples just to show you how all these look very similar, but you have to pay attention. Both of these are negative, so it gets to be a negative sum. Both of these are positive, so it's a positive sum. Here, the 5 3/10 is the larger decimal, and it's positive, so it gets to be a positive sum. And here, the 5 3/10 was the larger decimal, and it was negative, so it gets to have a negative sum. So I'll be right back with a few examples of subtraction. Okay guys, here we are back with pretty much the same numbers, just written with subtraction this time. Again, I'm going to go ahead and come in here, and for some reason the textbook likes to have parentheses around that second number if it is negative. The first thing I'm going to do is remind you guys of LCA, leave, change, additive inverse, or opposite is an easier word for that. When we're dealing with negatives, in addition and subtraction of negatives, we need to try to slow down and rewrite subtraction as addition. It's just one of the easier rules for it. So I'm going to do negative 5 3/10. I'm going to change this guy from a negative sign to an addition sign. Change this guy from a negative 64/100 to a positive 64/100. And now I'm going to look at this question to evaluate it. So again, this goes in the negative side. That goes in the positive side. So we're going to line up our decimals and subtract. And again, we get 4.66 when we evaluate this subtraction question. And again, let's look back here. And since we have most of the negatives right there, we know the answer is negative. Another way we can think about this is kind of close to -5. This is sort of close to -1. We're starting at -1, heading towards -5, so that means we're going down the number line 4 spots about, and this answer is relatively close to 4. So let's change this guy right here. Leave, change, additive inverse. I'm going to go ahead and put those parentheses around that second number. Let's go ahead and use our t-chart, negative, positive, 5 3/10, and then 64/100. So I'm going to be doing 5.30 plus 0.64 because they ended up in the same column. So that's a 4, that's a 9, and that's a 5. Bring the decimal straight down. And since they're both in this negative column, this difference is -5 94/100. -5 94/100 for that guy. Okay, leave, change, additive inverse. If we want to, we can use our t-chart. They both end up in the positive side of our t-chart. So that means we get to add those together. And again, we get 5 94/100. This time, since they're both in the positive side, it gets to stay positive. Now, some of you guys may notice this is just old school subtraction for question D, but let's just go ahead and pretend we didn't notice. 5.30. I'm going to go ahead and, as I'm writing this one out, make sure that both fractions are the same length, just because we know we have to line up our decimals. Plus negative 64/100. If I use my t-chart here, I get one number in the positive side and one number in the negative side. Anytime we do that, we know we're going to end up subtracting. I've already subtracted up here and got 4 66/100. This time it gets to stay positive because I have the larger number in the positive side. So that was just a quick recap of the integer rules that we need to follow when we are adding and subtracting any numbers. We need to follow these. These apply to fractions, decimals. So now instead of calling these the integer rules, we could call them the rational number rules because they are applying to every single number out there. So I hope this helped.